Okay, so let's create some functions in Python with Maya, right? So what we are going to do here is we are going to take what we started before, and we're going to expand a little bit the concepts of everything, right? I think that the most important function in PyML to retrieve an object that you have already created, like for example this cube. Imagine that I have many cubes. Oh, close. Let me create many cubes. Polygon cube options. Oh, the problem is that I double click. Okay, I need to make it slow. Anyway, if you want to retrieve some of these objects, which are called polycube x something, and you want to get them, I guess the easiest way to get them is to get them with PyML list. So PyML list is the function that will retrieve whatever you have in the scene and will turn it into a PyML object. It doesn't return just the name, it will return you the object, the PyML object, right? So I can select the objects, like in this case, and then I can click this button and selection PyML list. It's going to retrieve all the selection. But what if I don't have selection here? These objects are of type transform, so I could retrieve all the objects in the scene of type equals transform. All these are transforms, and I can print whatever I retrieve. Print. Let's print the selection, and let's see what we got. Okay, now it got me all the polycubes, but also maybe I need to print them in a for, so it's easy to take a look at them. So let's do for each in selection. Let's print them. Print each. Okay, there we go. And notice how it brought me everything in the scene that it's a transform. But in this case, it brought me also the cameras, the side, the top, the perspective. Each one of the cameras has a transform also. These are the transform attributes of a camera. So that's why it retrieved everything when I did of type equals transform. What else can I do with list? Also, a list can help me to retrieve things by name. For example, if I want the p cube 1, it's going to return only the p cube 1, right? But I can access this by name. If I want, I can put here an asterisk, which means that p cube and whatever name, which name continues here. This is a like a joker in poker. Like you can use it to define any character that matches after p cube. Let's run this. And in this case, notice how it returned all the p cube objects, but also it returned the shapes of the object. So don't forget that each one of these p cube has a shape underneath that in this case is called p cube shape. So that's why it returned all the shapes. So you need to be aware about that when you're calling things by naming. Or you can also add the type keyword argument equals transform. And in this case, if I put type equals transform, notice how the list, I hope it's going to be shorter. It's going to be just the p cubes transforms. No, don't forget that each p cube, it's not only the p cube. It has the p cube and it has the polycube input. So what about if I want the polycubes inputs? Let's do the polycube input. Polycube this. Polycube this. Don't forget that this is not of type transform. This is of type I don't know, cube creation or something like that should be. Let's print it just to see what type it is. So let's print the type. Print type of selection. Actually, I shouldn't print type. There is another function in PyML that's called PyML.list. No, I'm sorry. Object type. object type, and in this case the object type, I want the object type of the first element of my selection. All of them are going to be the same type, right? And we can print it, and now I got the polycube, and the type is polycube actually. And yeah, maybe I need to print something else here. Let's print also /n, which means it's gonna do a space. Let's run again this, and just you can see the space here. So this is the type polycube. Okay, and now I could modify the attributes. Don't forget that each one of these attributes can be accessed with they exist inside the object. So if I put here dot width, and I could here maybe get the width of the object. If I want to get it, it will be get. If I want to set it, it will be set. I'm going to set it to 5 maybe. So now all polycubes are going to be of size 5. Maybe I want to move them. If I want to move them, I want the transforms. Okay, let's do another final list, and let's do this with the transforms. Transforms equals, and let's do here everything that's called pcube, but that it's of type equals transform. Okay, and let's do a zip here. Zip, we are going to zip them, so it puts one by one. The selection, I said polycube. Now selection is polycube, but these are going to be the creations. I've named them. Okay, creations. Okay, and here in the zip, it's going to return two things: the creation node, so the pcube, and it's going to return also the transforms. Let's change the name to each to transform, just to be more clear. Obviously, the transform is not the one where I'm going to set the width. It's going to be the pcube, and the transform, I can move them. If I want to enumerate these ones, I want a range here, I want an index. Maybe I can just enumerate them. Enumerate this. I can do this, of course, but it gets a little bit complicated. I'm doing an enumerate inside a zip, so I need to put here my index like this, and then my pcube and my transform, I need to put them inside parentheses so they are returned correctly. So enumerate, zip, creations, transforms. So I'm going to catch here the index, which is going to be just a number 1 2 3 0 1 2 3, and I want to transform dot maybe the translate y dot set. I want to translate y dot set. I want to set it to the index value, maybe index value. Okay, and what about if I translate in z? And I'm going to translate in z with the minus index value, just a negative value, so it goes backwards. And let's try and see what we get here. We got some stairs, so each one of them, I'm translating them 1 unit on y and minus 1 unit in z, so they're going in that direction, right? And this was very easy, right? I'm creating this with already created cubes, but I could do it with new cubes. What if I don't have any cubes? I want to create the cubes. let's save this. This modifies something that was already created, and it's retrieving the selection with PyML lists. But let's do something that creates them from scratch. So to create them from scratch, I guess that what we will need to do is just create a polycube inside the range, a range or something. So we will need to do this. It's pretty similar to code. The only difference it will be that we need to create for each in. We are not going to enumerate. We are going to do a range because we want to do maybe 20 elements. And what we want to do, this polycube and transform will be retrieved from a creation of the polycube. So let's create a polycube equals pyml.polycube, and let's as I was saying, this returns the pcube and the transform. I have here the index, and I can keep this, and if the cubes don't exist, they're going to be created. Oh, there is an error. Has no attribute or method name with pcube1. I think I made a mistake, and maybe since it's calling pcube1, I think this is in the opposite order. First it returns the transform, then it returns the creation. That's why it's not working. Let's delete this and let's print it. And there you go. Now I have 20 stairs. So I have a script to create some stairs. I'm just moving, as I was saying, in X and then in Z. And this is pretty much the same. The only difference is that I can provide a number, right? I could turn this into a function very easily. Def stairs, and let's put the steps. It's my number of steps, and this is now a function where I can provide a number of steps to the stairs, and it's going to create as many stairs as I want, right? Let's delete this, and now let's change a little bit. What about if I wanna do something a little bit more complicated? Now I wanna do a wall of cubes. I can create my cubes as I am doing it. I'm moving them only in Y, but what I want to show you here is that you can create, I'm going to remove the function, that you can create force inside force, which it's called nested force. So for example, here in this case, you could do, we are doing index, let's call this index Y, and let's do another for each, for index X in, or index Z, let's call it, in range, let's do it of the same size. So let's put here a variable, steps equals 20, and let's put here steps. They're going to be the same size in range. Let's put here steps. What are we going to do? We are going to create a polycube, and we are going to set the width. Maybe we could set the width. Let's set it to something a little bit smaller. No, let's leave it like that, a little bit smaller maybe. By default is 1. Let's put it in 0.8, and let's also set the height to 0.8. So they are, even though they are together, you cannot see the height. Let's set it to 0.8, and if I'm not mistaken, the last one should be dipped, set to 0.8. And we are going to translate here Y. We're gonna translate the index in Y, and we are also going to translate in Z the index in Z. So these are two nested fors, as you can see, and let's try and click it, and what it creates. Oh, it created this. Something is wrong here. Oh yes, I'm setting the translate y, and in this case I should have translate z, modifying it, because I just created all the cubes exactly one after the other. There are 100 cubes. Let's try again, because there are more. There are 400 cubes, because they're 20 times 20. And what I am doing is I'm building a wall of cubes, right? Of 20 times 20 cubes with this code. Let's put a smaller number and let's make it in 3 axes. So we can put another nested 4. And now we are going to do it in X. Let's move them in X also. The same number of steps, and let's do it only for 10, because they're going to be a lot. They're going to be multiplied. Now they're going to be 100 cubes. And let's also add here a translate X and set it to index X. Okay, so these are 3 nested 4s, as I told you. And let's try again. And there you go. I have a cube made of cubes. If I go inside and I check inside this cube, there are many cubes, right? So it's very easy to create complex scenes with scripting. I hope this was clear. The nested, analyze a little bit the code. It's going first to increase the y-axis, so which ones are created first. Look, you can see it here. If I see it here is my cube of cubes. First it starts and it goes through the y-axis. Well, I'm sorry, y-axis is the last one, then is z, and then is x. So x is the ones that repeats the most. So first it creates the first cube and it goes through x. It's running the first part of the code here in X. Let me show you where. Here it's going to X, and it's creating each one of them. Then it's going to move in Z, and it's gonna go. The first time it did the first line, then the second time it does the second one, and it goes like this, increasing, as you can see in the Z axis, in the X axis and in the Z axis. And at some point, when it finishes all the X's and the Z, first it goes in X, then it goes in Z, and then it's gonna move in Y, right? So at this point, it continues, and then it moves in Y. Y increases. So Y is the last one that increases because it's the 4 that it's outside everything, right? So as you can see now, Y is increasing, and once again it repeats the Z and the X at the end. First moves in X, then moves in Z, then moves in Y, and that's how it creates all this range of cubes. I hope this was clear. Please analyze this code a little bit and try to understand how the nested 4s work, and if you have questions, let me know.